In this video, I'm going to show you the Excel skills for section 5.1, which is looking at the NORM.S.DIST function. So let's just go to that NORM.S.DIST function before we get started. So I'm going to get to it by going to Function Wizard, and then I'm in Statistical. I'm going to scroll down to the ends. And there's a bunch of different norm functions. We will learn all of these, but we're going to start off with just NORM.S.DIST. So this function we use with the standard normal distribution, and that's actually what that S tells us. That stands for the standard normal distribution. So we use this function specifically when we have a mean of 0 and a standard deviation of 1. So what's nice about this function is it's really straightforward. You put in your z-score, and then you put in whether you want it to be cumulative or not. And for these functions, we always want it to be cumulative. And the reason why, if you go back and read your notes, there's a pretty good explanation of it there, is that the normal function is a continuous function. So we cannot list out all points separately like we could with the binomial. There's an infinite number of points, and the area of any one particular point is so small, it's basically infinitesimally small. It's almost non-existent. And the only time we have actual values is when we put a whole bunch of points together. So for the NORM.S.DIST function, we're always going to put true for cumulative, or 1, saying that yes, we do want it to be cumulative. So this NORM.S.DIST function, it's always going to give us the area to the left of the z-score. And that's really important. All of the norm functions that we're going to learn are always in reference to the area on the left. So our first problem, it says find the area to the left of a z-score of 1.1. So when they're area to the left, that's easy. We just put in our 1.1 and hit OK. And it tells us that 0.86433 of the distribution's area is to the left, which that makes sense. If you visualize your bell curve, you've got 0 in the center, 1.1 is a little bit to the right. So we're shading everything to the left of that point, which is the whole left half of the graph, and then a little bit more. So we're shading well over half the graph if we're shading to the left of 1.1. So it makes sense that our answer is bigger than a half. Let's look at the next case. It says find the area to the right of z equals 1.025. Well, this NORM.S.DIST function, that's going to give us area to the left. That's not what we're looking for. But if we go back to the complement rule, we can figure out how to get area to the right. So visualize for a second the whole standard normal curve, or whole bell curve. The total area under the curve is 1. And that represents 100% of the possibilities. Just like when we were doing discrete probability distributions back in chapter 4, when we summed the probabilities, they always summed to 1. So the total area under any probability curve is going to be 1. So total area under the curve is 1. NORM.S.DIST gives us area to the left. Well, it's kind of like a puzzle. If we know the total area is 1, and we can find the area to the left, if we want to figure out what's left over on the right, if we do total minus left, that's going to give us the right. So to find the area to the right, what we have to do is we have to do 1 minus area to the left, which again, we find area to the left by using the NORM.DIST function, NORM.S.DIST, there it is. So our z-score is 1.025. For norm functions, we always put true. And so this is doing 1 minus area to the left, which is given by NORM.DIST, and that's going to give us what's left over to the right. So we have 0.1527. And again, this makes sense because if you visualize your curve, the center is 0, so 1.025 is a little bit to the right of 0. So if we're shading to the right of that point, we're shading less than half the graph. So it makes sense that our answer comes out to be less than half. Then our last case is finding the area between 2 points. So the big thing to think about is if we find NORM.DIST or NORM.S.DIST of 0.75, that gives us everything to the left of that point. If we find the area of negative 0.25, that gives us everything to the left of that. But we don't want what's to the left of this little portion. We want what's in between them. So we want to the right of 0.25, or negative 0.25, and to the left of 0.75. Well, the easiest way to do this is find the total area to the left, which is NORM.S.DIST of 0.75. And then right away subtract the area to the left of what's my computer doing? The area to the left of negative 0.25, because that's what we don't want. So I'm going to go up into my Excel and subtract the area to the left of negative 0.25. And so that's going to take out that little portion of the area we don't want, leaving us just what's in the middle.